function is defined by f of x is equals to e power x into sine x, and where x belongs to all the real numbers. So this is what is given in the question. And we need to find the Maclaurin series of this function, expanding it up till x to the power of 3. So from the formula booklet, we can notice that the Maclaurin series for e power x is going to be 1 plus x by 1 factorial plus x squared by 2 factorial. Series expansion for e power x would go something like this. And similarly, the Maclaurin series expansion for sin x would go something like x minus x cubed by 3 factorial plus x power 5 by 5 factorial and so on. Now, we need to find out the Maclaurin series for e power x into sin x, including the term x cubed. And you need to find it only up till x cubed term. So in that case, it's basically f of x is equals to e power x times sin x. We can also say it as e power x is going to be 1 plus x by 1 factorial plus x squared by 2 factorial and so on, and x minus x cubed by 3 factorial and x power 5 by 4 factorial and so on. And you have to just think about doing it like a selective multiplication. We don't have to expand it completely because we just need to get the term only up till x cubed term. So 1 times this x and 1 times this x cubed this. So these things I need to multiply it. So it's going to be 1 minus x cubed by 3 factorial, then plus x times x. So that's going to be x times x would be x squared divided by 1 factorial. Now, if I multiply this x times x cubed, that's going to give me x power 4, so which I don't really need. Then if I talk about x squared times x, so that's going to give me positive x cubed again, so x cubed over 2 factorial. So when I simplify this, I'll be getting it as 1 plus x squared by 1 factorial is just 1. Then we have minus of x cubed by 3 factorial is 3 times 2 times 1, which is 6, plus 2 factorial would be 2 times 1, which is just 2. So if I want to combine this, I need to multiply here and here with 3 and 3. So it's going to be 1 plus x squared minus, it's going to be plus 2x cubed over 6. So which can also be written as just 1 over 3. And this is the final answer for this part A. And this overall carries 4 marks. And the 4 marks distribution goes something like this. So recognizing the series from the formula booklet, this would carry 1 mark. And putting it as a multiplication, so this would carry your 2nd mark. And doing the right expansion, this would carry the 3rd mark. Of course, this is the 2nd mark. And the final answer, getting the final answer correct, so would carry 1 mark. So that's how the 4 marks are distributed for this sum. Next, for part B, hence find an approximate value of this integral step. So in order to do that, so first of all, we know this, e power x into sine x up till x cubed term. The expansion is going to look something like x plus x squared plus x cubed by 3. And this is what we have proved it. So in that case, if I talk about e power x squared into sine of x squared. So now when you compare these two things, so in place of x, we have x squared. So which we can just replace it. So in that case, when I do that, so it's going to be x squared plus this is going to be x squared whole square plus x squared whole cube divided by 3. And this is what is this. And we just need to integrate this one between the limits 0 to 1. So 0 to 1 x squared plus this is going to be x to the power of 4 plus this is going to be x to the power of 6 over 3. And when I integrate this now, so integration of x squared would be x cubed by 3 plus integration of x power 4 would be x to the power of 5 by 5 plus integration of x power 6 would be x to the power of 7 by 7, and there is already a 3. And now when we apply the limits, so when I apply the upper limit, so it's 1 cubed by 3 plus 1 to the power of 5 by 5 plus 1 to the power of 7 over 21. Then minus, when you apply the lower limit, every part will become 0. So 0 cubed by 3 plus 0 to the power of 5 by 5 plus 0 to the power of 7 over 21. So this entire thing will become 0. It's just going to be 1 by 3 plus 1 by 5 plus 1 by 21. So if I take the common LCM here, so it's going to be 105 is the common LCM. So in order to get 105, to multiply here with 35 and 35 in order to get 105 as a common LCM, and here with 21 and 21, and here with 5 and 5. So in that case, I'll be getting the common denominator as 105. And the numerator is going to be 35 plus 21 plus 5, which is going to be 61. And this is the right answer for part B. And this would carry 4 marks. And the 4 marks distribution goes something like this. 1 mark is for finding out the expression for this e power x square into sine of x square. That would carry 1 mark. And the second mark is for substituting it in the integral statement. That would carry the second mark. And the third mark is for showing up the integration. And the final mark is for the final answer. That's how the 4 marks are distributed for this sum. Next, for part C, the function g is defined by g of x is equals to e power x into cos x, where x belongs to all real number. Show that g of x satisfies the equation, which is g double dash of x is equals to 2 times g dash of x minus g of x. So this one, we just need to differentiate it and we need to solve it. So now, g of x is given us for C part 1. G of x is given as e power x into cos x. So now when I differentiate this, so I need to differentiate it using the product rule. So the derivative of this one is going to be, it's going to be the derivative of first term, which is the derivative of e power x would be e power x itself multiplied by cos x, plus the derivative of second term, so which is minus sine x into e power x. Now, this is, you can also write it as g dash of x is equals to, this is same as g of x. I'm just going to replace it, g of x, and this is nothing but minus e power x into sine x. Now, if I differentiate this equation for one more time, this is what I'll be getting at. So that's basically the second derivative, which is g double dash of x is equals to, if I find the derivative, it's going to be derivative of g dash of x, so it's going to be g double dash of x. And the derivative of g of x is going to be again g dash of x. You're replacing this e power x into cos x as g of x plays a big role. If I don't do that, so then probably I need to think about differentiating it twice. For e power x into cos x also, I need to apply the product rule. And for the second term also, I need to apply the product rule. And if I talk about this term, so it's minus of e power x, derivative of e power x would be e power x into sine x, plus the derivative of sine x would be cos x into e power x. Now, if I simplify this, it's going to be g dash of x minus, this is going to be e power x into sine x, and minus, it's going to be e power x into cos x. Now, if you observe it very clearly, This minus e power x into sine x can also be replaced with when g of x goes to the other side. We can replace this one with g dash of x minus g of x. So that's why it's going to be g dash of x. And this entire thing would be replaced with positive g dash of x minus g of x. So that's why it's going to be positive g dash of x, then minus g of x. And this is going to be again minus g of x. So that's why this is going to be 2 times g dash of x minus 2 times g of x. And if I take out 2 common out, if I take 2 common out, I'll be left with g dash of x minus g of x. And this is what we need to show. And this part would carry 3 marks in total. And the first mark is for showing the first derivative. So that's basically this particular step. So this would carry 1 mark. And the second mark is for either, of course, you can also do it without replacing it at this step. And at the last step, you can basically you can replace it. The second mark is for showing the second derivative, that is differentiating it. And the third mark is for replacing it and showing this. So this is how the 3 marks are distributed for this sum. Now, the next part carries only 2 marks, so which is C part 2. So we need to find the fourth derivative. So I'm just going to find the derivative of these things once again. If I find the derivative of this is going to be g of triple dash of x is going to be equals to 2 times g of double dash of x minus g dash of x, because the derivative of g of x is going to be g dash of x. Now, if I talk about differentiating it for one more time, that is the fourth derivative, this is going to be equals to 2 times g triple dash of x minus g double dash of x. Oh, sorry, the previous one carries 4 marks, and uh, 1 mark is for showing up the second derivative, and 1 mark is also for the substitution. So the previous part is for 4 marks, and this part is just for 1 mark. And that's how the 5 marks are distributed for the sum for part C. Next, for part D, using the results from part C, find the Maclaurin series for g of x. Now, whenever we talk about Maclaurin series for any function, so it would go something like this. So it's going to be g of 0 plus g dash of 0 into x by 1 factorial plus, and we need to find it up till 4th term. So it's going to be g double dash of 0 into x squared by 2 factorial plus g triple dash of 0 into x cubed by 3 factorial plus g of the fourth derivative 0 into x to the power of 4 by 4 factorial, and so on. And we just need to find out only up till the 4th term. So in that case, g of x is given like this. So then we know this g of 0 is going to be e power 0 times cos 0. E power 0 is 1 and cos 0 is also 1. So this is going to be just 1. And if I talk about g dash of 0, we found it in part C, that is g dash of x is going to be equals to g of x minus e power x into sine x. So in that case, it's going to be g of 0 minus e power 0 into sine 0. And sine 0 would be anyhow, it's 0. So this is g of 0 is going to be 1. And now we know this g double dash of 0 is going to be 2 times g dash of 0 minus g of 0. And g dash of 0 and g of 0. So both are 1. So that's why this will become 0. Then if I talk about g triple dash of 0, g triple dash of 0 is going to be 2 times g double dash of 0 minus g dash of 0. And g dash of 0 is 1. So that's why this will give me negative 2. And finally, if I talk about the fourth power, so that's going to be 2 times g triple dash of 0 minus g double dash of 0. G double dash of 0 is 0 itself, and this is minus 2, so that's why I'll be getting minus 4. So in that case, I can just substitute this one in the main equation, and I can just leave it up over there. So, or we can also simplify that. So if I substitute that, so g of x has to be equals to g of 0 is 1. Then it's going to be plus 1 times x by 1 factorial would be 1 itself, plus g double dash of 0 is 0. So 0 times x squared by 2 factorial would be 2. And plus, no, it would be minus g triple dash of 0 is minus 2 times x cubed by 3 factorial is nothing but 6. And finally, minus 4 times x to the power of 4 by 4 factorial is nothing but 24. And this is what is the right answer. Of course, we can also simplify this and say that the final answer as g of x is equals to 1 plus x. This part will become 0. And here we can simplify it. So it's going to be minus x cubed by 3, then minus x to the power of 4 by 6. And this is the right answer for the sum. And the 4 marks distribution goes something like this. So 1 mark is for trying to substitute and identifying that we need to substitute 0 in it. 0 for everything. So that would carry 1 mark. And the second mark is for, so basically these 2 things would carry, let's say, these 3 things would carry 1 mark, and these 2 things would carry another mark. So this is how the 3 marks are distributed. Then substituting it in the Maclaurin's formula. So that's basically using up this formula. So that would carry 1 mark, and the final answer would carry 1 more mark. So this is how the 5 marks are distributed for part D. Next, for part E, hence or otherwise determine the value of this limit. So we are talking about limit x tends to 0 of e power x cos x minus 1 minus x and entire thing divided by x cubed. So now from part C, we need to replace this e power x into cos x. So when I do that, so I'll be getting limit x tends to 0. E power x into cos x can be replaced with, we know it, it's going to be 1 plus x minus x cubed by 3 minus x power 4 by 6, and there will be other terms. And there is a minus 1 minus x and entire thing divided by x cubed. Here we can clearly see that this plus 1 minus 1 can get cancelled out, plus x and minus x can also get cancelled out. Now, but still if I apply the limits, I'll be getting it in the form of 0 by 0, so which is like indeterminate form. So I will be taking x cubed common out in the numerator when I do that. So I'll be getting minus 1 over 3 minus x over 6. The next term would be some constant into x to the power of 2, because the next term would be x power, just an example, it could be x power 5 or x power 6, whatever it is. So it's going to be some constant divided by something. So whatever the term I'll be having it, so all those terms will contain x. So here I can cancel out x cube and x cube. And because all the terms excluding the first term contains x, so when you put the limit, so all those things will become 0. So that's why the final answer is negative 1 over 3. And here the marks distribution goes something like this. So 1 mark is for using the substitution, that is from part B. And the second mark is for, let's say, factoring out x cube and trying to cancel it. And the third mark is for the final answer. So that's how the 3 marks are distributed for this sum.